Good afternoon, everyone. First off, a huge shout out to the organizers for doing a commendable job with the conference. Amazing first day. I attended some really insightful talks, so I genuinely hope that all of you here find something valuable in the next 45, 50 minutes. And yes, I've cut down the presentation from 60 to 45, 50 because I know it's 4:20. It's end of the day, it's post-lunch, that afternoon slump is kicking in. Most of us want to doze off. So naturally, I thought, what better way to start the talk by putting that visual up on screen. Now, you see that person smack in the center of the image? Well, in this story that I'm going to share today, that person is not me. I got trampled 3 screens ago, left for dead, nobody caring. But here I am, standing in front of you, rising from the ashes, rising from the dead to get you this story. Now, I absolutely love this picture. I genuinely do. I think it beautifully captures the chaotic energy that all of us developers have experienced from time to time. I mean, imagine the inside of that battlefield, the chaos, the battle cries, you feeling that everything is on the line. Well, that's how it felt to us sometimes when we were dealing with unruly business rules. And a disclaimer, you might see some more disturbing visuals during the talk, but rest assured, unlike the infamous finale of this web series, I assure you that our story has a happier and a brighter ending. And that gets me to my talk. How did we embrace this chaos that we were dealing with? How KMP helped us to solve some of the problems and or untangle the mess we found ourselves in a couple of years back. Yes, sorry. And yeah, just all the good surprises and not so fun surprises. So, and yeah, how KMP was our ally in this journey. Now, before we proceed further, I am Anshika. I'm a programmer representing a very talented team at Postal. If it would have been up to me, I would have had the entire team here on the stage because this has been a wild ride. And it's been a team effort through and through. I have 12 years of industry experience, of which the past decade has been with Postal. Launching and developing solutions which enables millions of people in and around Nordics and thousands of businesses to receive and send packages. And how I've compartmentalized the talk is that we will get the lay of the land, we'll address the problem statement, then we will talk what KMP is all about, how it helped us in our use case, and then wrap it up with some, yeah, not so fun problems and all the benefits we've experienced after adopting this technology. So let's get started. Let's swap sword from that first picture with code and get right to it. Now, complex world of logistics. I haven't put Postal there because it's not a Postal problem. Logistics, like any other industry, is inherently complex. You might ask how. Let me give you an example. When you order that stuff online, maybe you're ordering a t-shirt online, right from it leaves the warehouse till it reaches your doorstep, there are millions of lines of code and thousands of business rules that enable that flow. Now, how many of you have heard of Postal before today? Okay, I expected that in Oslo. But for the ones who haven't raised their hand, I can just give you some context. Imagine an institute as old as your great-great-great-great-great-grandparent. I mean, people who raise their hands know about it, have used it. Some of you might have grown up with it, and rightly so. We are one of the oldest organizations in the country, maybe even in the world. We are almost 400 years old. We just celebrated our 378th birthday. And of course, the software hasn't been around for 400 years, but it has been around for decades. It's been worked on by a lot of different developers. So you can say that we were dealing with a generational software. And that was part of the challenge. Now, what you see on the slide is just tip of the iceberg. That's me trying to really, giving you like a layman explanation of what we deal with day in, day out. So diverse services is when you're ordering something online and you say, hey, I want it on my doorstep or to a pick-up point, like a Rima or a Many, or to like a parcel locker, all of those are different services. Coverage is whether it's Norway to Sweden, Norway to Germany, and so on and so forth. Customer access and special rules, all the dimension rules that are attached with delivery of a shipment. Now, when I joined Post and Bring a decade back, we had this huge monolith. And I see some people nodding, and exactly the image that you get in your head. You know, you're new to the company, you're excited, you do that git clone, and then you go get your coffee, you make new friends, you do all the small talk in the world, and when you come back, it's still downloading the history of the universe. Exactly that. But over the years, but there was one catch here. Even though it was a huge beast, all of the business rules that I'm talking about was centralized in that monolith. Now, over the years, because of microservices and feature development, it was decided that we will break down this beast into multiple manageable apps. So what you see on the screen here is just visual representation of that. So it's a composition of public APIs, private APIs, like internal APIs, front-end apps, back-end APIs, everything. Now you can see the caveat. And mind you, we were reaping the benefits of not having to deal with that monolith. Oh, it was working out fabulously well. But for this one caveat, you can see X there. X is a representative of a business rule. And now you see our business rules were all fragmented. There was no one single source of truth. It was differently implemented in different apps. Now, show of hands, how many of you have been that person sifting through millions of lines of code trying to understand what on earth is this code doing? And how many of you have cursed the predecessor who's written that code? Everyone. And rightly so, because 60% of the developer's time is spent on understanding code. More than writing code, we are trying to make sense of what our predecessors have done. And that was one of the biggest challenges we were facing. And apart from that, another thing that was a really pain was debugging these apps. And I'm not talking about the production issues or bugs. I'm talking about a very simple request from our product owners saying, hey, how is this feature implemented in this API? All of the developers used to, I was the team lead on the team, so I was protecting and shielding the developers. So I used to spend hours debugging these apps only to realize that these rules were differently implemented in each app. And so it really was playing whack-a-mole. And of course, there was some price to this chaos. Now, of course, like I said, inconsistent rule set, slow feature development, painful production deployment, fear-driven development. And when I say all of this, I mean it used to take us months to introduce a new feature in. Like right from planning to deployment, it was a very, very slow process. And even when we were deploying, and we were deploying multiple times a day, so I'm not going to say that we were never confident in the feature flow that we were deploying, but sometimes we were not because of all the fragmentation that we were experiencing. It was a problem for us. And if I have to sum it up, I would say people who were dealing with this code base were just an unmotivated lot. We were frustrated with the code base. And I think in my understanding, that's the biggest red flag you can have in the team. So what were we chasing? Of course, we wanted a centralized rule set. We wanted duplication to go take a vacation. I'm rhyming now. We wanted manual testing and manual testing and maintenance to take a nosedive. And what we really wanted was this. And I hope that a Lord of the Rings fan in the room would appreciate that visual. Because this is what we wanted. We wanted one code base to run them all, exactly like one ring, but not to yield dark powers, but just to have some semblance of control over these unruly business rules. And my personal favorite, that what we wanted here was the last point on the slide. It's the last point, but in my head, that's the most important thing you can have in the team, and that's developer happiness. Because in my 12 years of experience, I've realized that if you're green in that section, then inherently you're doing everything okay on all the aforementioned points. Now, we had this huge, ambitious plan in front of us. How are we planning to achieve this? I think the saying goes, how do you eat an elephant? And it's one bite at a time. You see, because we had this huge ambition, we just needed a plan of action. So what we did was, in 2019, we made a plan with our product owners, and we decided that we will do technical refactoring as part of every business feature that we get. So in 2019, whenever we got a business feature, we started plucking out these business rules out of these different apps and dumping them in one common library. Now, this library was spitting out a JVM artifact, which was then used as a dependency in all our backend APIs. So that person that you related to a couple of slides back, they heaved a sigh of relief. They were like, OK, there's some semblance of control here. There's some single source of truth. For all our backend APIs, at least we can say everything is coming from this common library. But that happiness and that relief was very short-lived. You see, we also had front-end apps. So come 2021, we did it for 2 years, one small step at a time. So come 2021, when we got another business feature request, which had something to do with front-end apps, we realized, hey, our front-end apps are still that monstrous octopus with tentacles everywhere, with business rules everywhere, fragmented. And we had spent 2 years on that library, on plucking out these business rules and dumping them in this common lib. So you can understand we didn't want that effort to be wasted. We somehow wanted to use that common library to also power our front ends, to also validate our front ends, instead of creating another library which would then be used in JavaScript. We just wanted to use one library. And I think that's a nice segue into the next section of the talk, multi-platform. But before we dive into the specifics of how it helped or how KMP helped us in our use case, we need to understand what KMP is. And no deep dives because it's a huge subject matter. But I'll talk about it enough to give you, if anyone has never heard of it, you'll have a foundational understanding of what KMP is and all the technical jargon and everything. And I will share some code snippets later on in the talk, so it will help you correlate with those code snippets as well. OK, so let's get started. What is Kotlin Multiplatform? That's the first basic question. It's an open source technology. This is a watered down definition by our team. This is how we understand it. So it's an open source technology developed by JetBrains back in 2017. I think they announced it in Kotlin Conf. So it's been around for 8 years. Very simply put, it allows developers like you and I to write and share common code across different platforms. Let's chew on that a bit more. Let's elaborate that a bit more and talk about platform it supports, most common use case. Fun fact, it's not our use case. The most common use case that this technology is being used for today is something else, and I'll talk about it in a minute. And some technical jargon that you're seeing on the slide, which I feel if you talk about KMP with someone, then it would be nice if you are aware of this. Now, before we proceed there, I just dumped this into the deck because when I was sending in my proposal and when I was preparing the talk, I actually myself was confused because when you go out and you want to, like you read blog posts or see video tutorials or any other thing, you will see that there are a bunch of acronyms, plethora of acronyms out there floating. But JetBrains came out last year or last to last year, and they just said that it's KMP. It's Kotlin Multiplatform. Irrespective of what platform you're using it for, it's just called Kotlin Multiplatform. Not so. If any of you want to read up on it when you go out of the talk, just don't get confused like I was, because otherwise you're like, OK, is it the same technology or not? So just wanted to throw that in. Now, platform it supports. You can see that it started with server-side. That's what we are using it for in our use case. And then it shifted focus to mobile platforms. So this is the most common use case. And it's a very logical reasoning behind it. Kotlin, even though it has seen a steady increase as a server-side language in recent years, it's still predominantly used in Android development. So of course, JetBrains just shifted focus to where their user base was. So that's why mobile platforms is the most common use case that KMP is being used for today. So, and it supports iOS and Android. Desktop is Mac OS, Linux, Windows, and so on and so forth. And web is JS and WASM. So JS and server-side is what we are using it for in our use case. Now, you can see that it has a huge, extensive list of platforms that it supports. Now, the million-dollar question is, what do you share? You have all of these platforms, but what do you share? And that's where our team feels that KMP really shines. I think it really differs and from its predecessors and its contemporaries here. It's the flexibility for us. With KMP, you're not committed to do a full-scale migration. It's not a zero-sum choice. It's not a binary decision. It's not all or nothing. So you can start really small when you are trying to adopt this technology. And that really clicked with our team when we were doing the POC first. So as it says on the slide, you can either share like some part of your logic layer, or you can share the entire layer, or you can share both UI and logic. Let's just elaborate a bit more on that. Now, most common use case, like I mentioned, is for mobile apps. So that's why I've put the visual of a mobile app there. How many mobile app developers in the room? OK, few. I'm not a mobile app developer. But all of us, I hope, are cognizant of these architectural layers already. If not, I can just quickly do a run-through. So data core is something when you are fetching data, either from a database call or from a network call to an external integration. Business domain is what I've been going on and on about in the last 15 minutes. And UI and presentation is just you clicking through views. Now, without KMP, imagine business comes to you and says, hey, I want you to build an app for these 3 platforms. Now, without KMP, you will have 3 code bases written in 3 different tech stacks, maybe 3 different teams. Now, imagine the amount of overhead and maintenance and testing cost of maintaining all these 3 different code bases, which is basically the same business rules being repeated 3 times. With KMP, like I said, you can either start with sharing your business domain layer, all those business rules. Or if you're getting more adventurous, you can start sharing the data core layer or presentation as well. Now, you see there is a progression here. Again, a disclaimer, and I'm repeating myself. You can share all the layers here, but you're not required to share them. And that's the beauty here. It's you do you. Whatever is your use case, you can just share 1/10 of one layer. You're not required to share all the layers here. Now, with KMP, the UIs will still be written natively. So you will have Swift UI for iOS, Jetpack Compose for Android, and so on and so forth. And I wanted to add this here because we feel that this is a very ambitious project by JetBrains. So the difference between the last slide and this slide is that in this, so Compose Multiplatform is a framework which is built on Jetpack Compose. And for people in the room who are not mobile app developers, Jetpack Compose is nothing but UIs written in Kotlin in a declarative approach, as simple as that. So what JetBrains has done is it has taken Jetpack Compose and built this framework on top of it, basically extending the capabilities to other platforms. And this is still in experimental stage, but imagine when this is out in production and stable, you can, in principle, have one code base with all these layers written in one language, Kotlin, and then you can run it on different platforms. Of course, the platform-specific logic would not go here in the common source set, and for obvious reasons. But this really would revolutionize, I don't know, app development. There are some teams in our company who are dabbling with it. Let's see how it works out. Now, some technical jargon, like I said, it would be nice if you're aware of what these terms mean. Now, this is a very common project structure of a Kotlin multi-platform project or a library. Naturally, your eye would be drawn to that shared module. And with these three source sets, common main, iOS main, JVM main, you can have JS main, uh, Android main, and so on and so forth. Now, common main is where you as a developer would write code which should be compiled to all different platforms. Now, I had this question when we started with it, like, why can't I just dump everything in the common main? And in an ideal world, that would be perfect. But in reality, when you are building an app for a platform, there are certain tasks for which you have to talk to platform-specific APIs. And Kotlin compiler, by principle, will not allow you to write code for which you have to talk to platform-specific APIs in common main. And the reason is very simple, because common main needs to compile to all platforms. So everything that goes in there should be platform agnostic. And that's why we have platform-specific modules or source sets. So that's what iOS main, JVM main, JS main, Android main would have. And how the dynamics work between these platforms is with expect and actual mechanism. Let me give you an example. So suppose you're building an app, and then you have a feature request saying, hey, I want to extract the underlying operating system of the platform that the app is running on. Now, you would see in common main, you will declare the platform agnostic function with the keyword called expect. And now, if you're using like Fleet or IntelliJ as an IDE, it will give you a compile time error because it will expect you to have a definition of this declaration defined in the iOS main and Android main. So on this side, you will see, for the iOS main, you will see the actual definition of that function with the keyword actual, where it is talking to the Apple platform-specific APIs. And similarly, for Android-specific APIs, you'll see the actual definition there, and we are fetching the underlying operating system. So that's why we need two common main and platform-specific modules. Another thing is called targets. This is nothing but a developer telling the Kotlin compiler, hey, you need to build this app or project and compile it to all these different platforms. And when we specify that in the Gradle build script, you will get a JVM class file or a JS file or native executables or binaries. Now, source sets and dependencies. This is a fancy term, but in short, it's POM. It's either a POM, or if you're working with Gradle build script, it's that. If you're a front-end developer, then it's package.json. It's as simple as that. The only difference is that when you're declaring these dependencies to compile your code, you have to categorize them according to the source set. So if I give you an example from our code base, we have extensive amount of unit test cases written for our JVM module. And that needs JUnit dependency, and that goes under JVM test. It's POM, but you need to categorize it around, according to the source set. That's it. That's the only difference. OK, so let's just wrap this deep dive on steroids with these visuals. Actually, all the visuals were from official JetBrains website. Now, I would highly encourage everyone to go read the case studies, because some of the names there at least gave us the confidence back in 2021 to dabble in a POC here. Like some of the names, there are apps that we use every day in our life. And if they were using KMP in production, it just gave us some confidence that, hey, at least we can do a POC with this technology. 2021 is when we started dabbling with it, is also when it took off. And another visual that I wanted to share was which layer, like all those architectural layers, which layer is being commonly shared the most. And you will see the winner there is data validation and serialization. So if I repeat myself from beginning, it's not a post and bring problem or like just a logistics industry problem. It's prevalent everywhere. So I would really recommend you to read some of the case studies. Maybe you'll find your use case there, and it will help you find a solution for your problem. OK, now that we've dipped our toes in KMP and have enough theory to help us understand better. Let's get back to our story. Now, why did we start with KMP POC back in 2021? First of all, it employed Kotlin. So all our apps, or most of our apps, were written in Java, and we were using Maven. So our understanding or our assumption that because Kotlin is interoperable with Java, we just assumed that we won't have to rip out everything and start from scratch. The learning curve wouldn't be that steep, and it should work seamlessly with our existing framework. And we were correct. It had, and it still does, has a very strong community support. Whenever we've posted a question on their Slack channel, someone really, the replies are prompt, and they help us with any query that we've had in the last 4 years. It supports diverse build targets, like I just talked about. And yeah, had a proven success with leading industry players. That really gave us a lot of confidence seeing those names up there. And it has a good ecosystem of libraries that you can use and thorough documentation. And option to extend to native targets in future if necessary. So like I said, our team doesn't deal with mobile platforms, but Postal Bring has a lot of apps that most of you are using, like Sporing. And the teams that own those apps, like I said previously, have started seeing our success with the KMP. They've started to now dabble in to refactor and just try this, both Compose Multiplatform and KMP for our mobile apps. Hopefully they'll have a talk next year or sometime in future explaining what all benefits did they see with it. OK, so let's dive into the code. I fear demo gods. I've had demos before here, but it didn't work out well. So I have code snippets this time. Now, first question that was in my head when I heard of this was, OK, if you want to go out of this talk and do a POC yourself, how do you get started? So the answer to that is very simple these days. You go to kmpjetbrains.com, and you either get a template or a wizard, and you just select which platform you are trying to build your app for, and then boom, you get a project structure out of the box. You don't have to create those modules yourself. It just does it for you. And now that we've gone through that theory, hopefully this visual will make more sense. So what you see here is the common main, the JS main, and JVM main, because we are dealing with just Java and JavaScript. Now, common main has all the business rules that I was talking about previously. All of those are dumped in common main. What you see is just a slight snippet of what I was allowed to share in the talk by my employer. But everything, like complex business rules, everything is dumped in common main. Now, your question would be, OK, then what do we have in JS main and JVM main? Now, we need methods or classes or interfaces to expose that rule out to our backend APIs and frontend apps. Let me give you an example. We have a lot of fun methods at work, but I chose this one because why not? Is shipped by boat. Now, there are a lot of rules defining whether a shipment can be shipped by a boat or not. Not relevant here, but all of those rules go in the common main. What we have in the JVM and JS main are these methods. And this is a very, very simple method that I've taken for the talk, just to explain what happens here. Now, on the first glance, you will see, or you will think that, hey, it's the same method, just repeated twice in JS main and JVM main. Yes and no. Now, Java, in JVM main, you will see that Java allows for more complex and strongly typed code. So you will see enum in the function parameters, which will not fly with JavaScript. So you see string there. Another important difference is the annotation. Now, JVM static has nothing to do with KMP. And it's just when you're writing your code in Kotlin and you want to access that method statically in your Java app, you put that annotation in. But JS export, that is a very crucial and important annotation. That has to be put in on that method or an interface or a variable or a class, because that tells the Kotlin compiler to take this method and make it part of the built-in JavaScript library JS files that is spit out with all the TypeScript annotations and everything. So it basically helps in making this method directly accessible in our JavaScript files, making it a global object. And how, OK, now that we've introduced these methods, how do we use them in our apps? For first, like I said, we have to define targets. And like I said, we just do JVM and JS for our use case. But if you're dealing with more platforms, then you will have all those platforms listed as well. Once you've defined the targets, you will basically be telling the Kotlin compiler will take the common main, which has all the business rules. It will combine it with the JVM main, and then spit out the JVM artifact, which is then used as a dependency in our backend APIs. And similarly, common main plus JS main will spit out an NPM artifact, which is then used in our front-end apps. And we have, like I said, we used to do a lot of manual testing before we had this setup. That's out of the window. We no longer manual test any of our features unless it's a very complex business feature. Then we'll have someone from the business side test it. But we have robust amount of test cases written. Unit test cases, integration test cases, we just merge and it just pushes to production. And we know that it will work. Now, you have those artifacts. You have to publish it to Maven and the NPM publish to use into your front-end apps. And the last line of code there is basically us telling the Kotlin compiler that do not spit out any native binaries because we don't have any mobile apps here. Now, how do you use this dependency? Like any other dependency. So whether you're using POM or Gradle build script or package.json, just use, like when you publish it to Maven, you can download that as a normal dependency and put it in your actual backend API or front-end apps. And this is how we would call the method or the class or variable or interface, anything that we've put in the KMP library in the actual apps. So you see in the backend APIs, it's like shipping rules is shipped by boat, and then we just pass the country, and it would run all the rules and tell us if it will validate the rules here in the backend API. And similarly, because of that annotation, you can actually import it as a normal JavaScript function in your JavaScript files, and then just use it like a normal JS function. So it's as simple as that. Now, like a very good side effect of doing this, of having this centralized project for us, for our rules, has led to us having, OK, I can start with the problem statement. So we have a developer site, which had some of the business rules mentioned there. And we used to get a lot of cases from our customers saying, hey, your dev site says this is allowed in this country coverage, but your API is not validating according to what your documentation is saying. And of course, we don't expose out all the business rules on our dev site, but the basic ones. But we used to get a lot of complaints because it was always outdated. But now that we have this KMP library, we use it to generate a JSON, which then powers this HTML page. And it's all automated. So our dev site is actually a live documentation. Every time a rule is changed in our KMP library, it just auto-magically reflects on our dev site. And we didn't intend for this, but this is a very nice side effect that we are really, really happy with. Oh, time flies really fast. So have we demystified X, that person we related to in the beginning of the talk? Well, I would say a resounding yes. This is no longer a wild goose chase. We know what X is because now all our rules, or most of our rules, are in that centralized source. It's not fragmented everywhere. So I would say that this person has joy in their heart, spring in their step, and some color in their life. And I really mean it. I am that person. I have been on both sides of the picture here. But is it all sunshine and rainbows and unicorns? Well, no. This is my message and my pull request from last month, actually, where I am asking my product owner and the business developer, hey, what is the actual rule here? because locally that API was saying, or it had implemented, it was still using the local database to fetch some rules. It wasn't using the KMP library. And it's like we've been doing it for 4 years, and it's bit like trying to clean out your garage, if you know what I mean. It's like you have one adamant box always there that you need to clean up. So I would say that there's still a trek left here. But it's not like we are not wandering aimlessly anymore. We know where we want to go. We know what we want to achieve. So we're just taking small steps, one at a time. Now some insight gains. Let's see. Did we achieve everything that we set out to achieve? I would say yes. We have this centralized source of rules, so it's not fragmented anymore. The amount of time that we used to take to develop a feature and ship it to production has reduced drastically. The time to market has reduced a lot. From like months, it takes us days to launch a new service and put it out in production for our customers to use. We no longer test manually. Like I said previously as well, I'm just going to repeat that because of that centralized library and all the test coverage that we have for all the rules and the validation that we do, we are actually confident of our code changes when they're pushed to production. If the build is green, then we don't worry about if this is going to fail in production for any of the systems in the feature flow. My team is not here, but I can say that Mondays are fun. People are happy in the team. They look forward to come work on this and other stuff on Mondays. It's no longer a frustrated lot that we were before we did this POC. Now, centralized documentation I've already talked about. My personal favorite is making our product owners self-sufficient. Now, I mentioned that anecdote in the beginning of the talk, saying that my product owner used to ask us, how is this implemented? How is this rule working out? And we used to spend hours debugging that. That is no longer the case. Our product owners are rock stars. They have GitHub accounts. And Kotlin is simple. It's intuitive. It's readable. So now when they ask us, we share that Kotlin file with them. And not only are our product owners reading the code, but they are actually creating pull requests. Let me give you an example. Very small things. If there is a max weight change for a service from 30 kilos to 40 kilos, it's no longer a Trello card. It's no longer like a planning session, getting all the developers and discussing it. They just raise a pull request. And of course, it goes through developer review. They're not going batshit crazy with the code here. But it has just improved the relationship we've had with product owners because they somehow now understand where we are coming from. This could be another talk. The benefits we've seen with our relationship with our product owners and in business, like with business in general. Another thing is it has helped us have a more streamlined, aligned workflow. So if you remember that picture with all the different microservices we had, so all of those were not handled by one team. There were different teams handling those apps. And initially, if you had to have a feature flow implemented on all different apps, the amount of coordination overhead with other teams was immense. But that also has reduced because now all of us have this one centralized source of truth, so we have to make the change once, and that every team just gets the change automatically in their apps. But it hasn't been all, positive and just benefits here. There have been some bumps on the road. Now, tech transformation trials, I would say we started with this POC in 2021. Now, KMP is stable and it's production ready. It was production ready in 2023. So I can completely understand when we went to our tech leads in 2021 saying, hey, we want to do this POC for, and mind you, like it's powering some of our most critical apps, which generates revenue for Postal and Bring. So I can understand their hesitancy back then. And of course, we were running a risk of siloed skills because it was just few of us who knew what we were doing. But over the last 4 years, that has gone away because we've ensured that all the team members have worked on this and are aware of what all changes we've done to the structure or to the architecture of all the apps we own. Now, library limitation and experimental features. Because we started with it in 2021, JetBrains was spitting out feature after feature every single week. So we had to be on our toes to keep up with them. Because, like I said, it's been stable and production ready now in 2023. So for 2 years, we were, we were using some annotation and it was getting deprecated and we had to use something else. So we really had to look out because this was in production running at our end as well. So I would say that was a bit of a challenge to keep up with all the new features that JetBrains was spitting out for KMP. Now it's not that. So they do have more new features, but it's more stable and not that frequent at it as it was in 2021. Kotlin Climb and Gradle Ascent. Like I said, most of our apps were written in Java, and we were using Maven. So I won't say like the learning curve was very steep here, but we had to make a shift to start using Kotlin and Gradle. But it was, like I said, our assumption that it would work out seamlessly and would work with our existing framework, that held true during the POC. One thing that we saw was that the generated JS packages could become really large. But with Webpack 5 support, you can, if you face the similar problem in your projects, if you try this out, we've used Webpack 5 for like optimizations there, and it has worked out really well. Again, my favorite here is piggybacking technical changes. I hope you're aware of that acronym. It's called What's in it for me. And that's what business tells you. So like I said, we were doing this technical refactoring, which we started in 2019, and we're still doing it because, let's be real, no company would give you money and time to just do this technical refactoring. And we weren't doing just this. We were rewriting our apps from Ruby to Java or Kotlin. We were from native JavaScript to React. So a lot of different things were going on in parallel. And nobody was, Again, hats off to our product owners because they, with the developers, devised a plan and talked to business and made them understand in a language they understand, and that's money. So when they see that result of this technical refactoring over the last 4 years, in small steps, we just had to put our foot down that every time we get a business feature, we will pluck out those rules. We will do some technical refactoring here. And if it takes 2 weeks more, then so be it. Because now business sees that when we are launching those services in 2 days, they see the benefit of piggybacking these technical refactorings over to your business features. That's our biggest takeaway from this, even though it was a challenge at the beginning. But I think now when we go to business and say, hey, we need to do this technical refactoring, there's a trust there. They've seen the benefit of us doing it for 4 years, so now they don't even bat an eyelid, and they just say, okay, yeah, go ahead. Take 2 months extra, but and do your technical refactoring as part of this business feature. Landing a structured approach to prevent conflicts. So like I said, there were multiple teams owning those multiple apps, and all of us were using this common library. Now, initially, we were stepping on each other's toes, because if I made a change in the library, how do I ensure that the other team knows that I've made the change here? Now, the system we have in place, it might sound a bit bureaucratic, but it works for us. Might not work when we scale out, but right now it's working out really well for us. So we have a rule that if I raise a pull request in that library, someone else, like the team member from another team, has to review. So I can't just get my team members to review and then push it to production. We make sure that it will not, the code owner is from the other team needs to approve and review the PR. Just so that, because in our head, if one person from that team knows what we've done, then we are good. Another thing is, because it's a library, so we spit out, there's a new version every time we make a change to this common library. So initially, we had to ensure all those apps were manually updated with this new dependency, and that was also causing a lot of problems. But that has been solved with Dependabot, GitHub Dependabot. So for every other, like any other dependency that we have, every time there's a new version for this library, it just creates a pull request in all the apps that use this as a dependency, and then because we have those robust amount of test cases, so we just merge the pull request and it just goes to production. And in last 4 years, we've not broken production with this because we really have a very tight set of test cases written around it. Okay, so hope you're ready to untangle your spaghetti and you learned something new today and found something valuable in the talk. And just some last takeaways here. I would say start small, and I'm going to repeat. That's the beauty of KMP, that you can start really small. I'm sure every project here has those pesky constants that are repeated in every code base. Just rip those out and put them in the library. As simple as that. You can start as small as that. And then share more code or share more layers between your apps. But yeah, another thing is just stay flexible. It might come across that I'm like a spokesperson for JetBrains. I'm not. I'm not getting paid for this talk. But KMP has really worked out really well for us. But it's fine if it doesn't work out for you. There are other technologies to get a solution to the same problem. So just roll with the punches and own your approach. And yes, I know it's too late in the day, so I don't want to keep you any longer. Thank you for joining, and thank you for listening in.